Hey guys, how's it going? Alright guys, I'm just gonna do a quick little video on integration by parts for you guys over here. So, back up for a sec. So, what I like talking about how to start integration by parts is when I look at two different examples. First question is, so I'm going to do this one with the integral of x e to the x squared over here. Okay. Now in this case, this is going to be a very good u substitution question because if I let u equal x squared, that's this part here, my derivative is 2x, and that means du over 2x equals dx. So the whole thing about integration by substitution is that when we get to this step, we get the second part cancels out. So this ends up being 1/2 comes out, integral of e to the u du equals 1/2 e to the u plus c, which is 1/2 e to the x squared plus c. Okay. Now, if I try to do the same thing, I'm just going to make a different question here. So this is kind of example number 1. Now, example number 2, and we're going to see that this is not going to work here. Okay. Now, so this is almost the same question but instead of having an x squared, I just have e to the x like this. And well, it's just not going to work because if I let x equal to u, that means du dx equals 1. That means du equals dx. Well, I was unable to cancel out this x over here. Okay, and that was a step that was kind of that had to happen for integration by substitution to work. Okay, so this one over here is integration by substitution, and this one over here is integration by substitution won't work. Okay. Prove what we call the integration by parts formula. Okay. So example is like if I had something like this, y equals cos x, okay, well, that's so like this would be like my u here and this would be my v over here. So u and v are both going to be functions of x, okay? But here's what we're going to do. If I take the derivative, okay, now I'm slightly changing my notation over here, okay? Now, all I'm saying over here is that really this is just my product rule. First, so and again, guys, I'm taking my derivative here. I'm not taking the integral here. Okay, so if I go first, second prime, so u is the first, and dv means the derivative of v, and then plus v du. So it's the v times the derivative of u over here. Okay, so this is what the derivative of this guy is over here. So now what we're trying to get at over here is like, well, if you take the so if I take the derivative of something, sorry, if I take the antiderivative of that, it should take me back to the original. So if I take the antiderivative, which is the same thing as taking the integral of this part here, well, what should this antiderivative equal? Well, it should equal uv, which is this part over here, right? It's like I started with uv, I took my derivative, which is this guy over here. Well, if I take the antiderivative of this, it should take me back to this guy over here, okay? Now, there's brackets over here. We had a rule, guys, that if you were taking the derivative of two things that you're adding, I can just take the antiderivative of this part and the antiderivative of this part over here. So I'm just going to do that. So this is going to be the integral of u dv plus the integral of v du equals uv. Okay? And then I'm just going to do this, integral of u dv equals uv minus the integral of v du. So all I did was I subtract the integral of v du from both sides. Okay, and this bad boy is our very sweet integration by parts formula. Okay, now guys, when I had to learn this stuff, and guys, because you weren't even have, so you guys have to know this formula over here, and you guys need to have this one memorized. Okay, I'll double check, guys, but like I think for your in-class test, guys, we might give you this guy on a formula sheet, but for your AP test, you won't. Okay, here's how I memorize this. Okay, now, guys, some teachers disagree with this method, or they don't disagree with it. They don't understand this method, guys. To tell the truth, like that, right? But I'm going to commit to it. I've committed to this stuff for the last 20 years. It's worked very, very well for me, and I hope that it works very, very well for you guys. Here's how we memorize this guy. It's called FUDOV of Vidu. All right, so here's what FUDOV of Vidu means. Okay, so this is an integral of u dv. Well, this sign over here kind of looks like a big F, u dv. This one spells the word FUDOV. If you look at the uv parts, well, of is like the word of. Now this part over here, well, we're just going to pretend this guy's not here. VDU kind of sounds like the word Vidu. Okay, so this is like probably going to be the last McMahonism that you guys are going to learn over here. But FUDOV of Vidu is how we memorize our integration by parts formula. Okay, now guys, this is going to take a lot of practice to learn how this works. Let's go. So if this one over here, our integration by parts formula is FUDOV, the integral of u dv, of uv, Vidu, the integral of v du. FUDOV of Vidu. So what we're saying here is that u equals x, dv equals cos x. Okay, now we need to figure out, well, what's du and what does v equal? Okay, well, in this case, if I take the derivative of x, this would be 1 dx. So it's going to be du equals dx, or it's du equals 1. Okay, I'm just going to do this. Let's do this. Let's go du equals 1. Okay, now if dv is cos x, this is saying that the derivative of v is cos x. So what does v have to be? That means v has to equal sine x. Okay, all right, so what do we have here? We have FUDOV of Vidu. So that means the integral of x cos x equals uv, the of part, u v x sine x minus the integral of v du. Okay, now why is this working the way it does? Is what we've done here is we're not done yet, because we still have an integral within the integral over here. Okay, but what I've done is like I've taken something from x cos x, which is two parts, and x is the first part, of cos x is the second part, and I still have this part out in front, but I've taken down to a much simpler integral in this second part over here. Well, what's the integral of sine x? We know that it's going to be positive cos x, right? So this is going to equal x sine x plus cos x dx. So plus cos x plus c. Okay, and this is going to be our answer for this question over here. Now, I'll start here. I'm just going to do a little check. How do you do a check? Well, since this is an antiderivative, if I take the derivative of this expression, it should take me back to x cos x over here, okay? Well, what's the derivative of x sine x? I'd have to use product rule for this guy over here. First, second prime. So x derivative of sine x is cos x plus second first prime. Derivative of cos x is negative sine x. And the derivative of c is just 0. Okay, so what we get here is we have x cos x plus sine x minus sine x, and those guys just cancel out, which gives us the x cos x that we had at the very beginning over here. Okay, so guys, let's say this again. Fadv of Vadu. And guys, I'm aware that there's a lot of flaws in this thing over here, but like this is how I memorized this guy over here. I've taught this for years, and I've had people come back to me afterwards and say, hey, you know, all the engineers at Queen's University now know Fadv of Vadu because they all had to memorize it like that, you know, and it kind of saved them for a few tests in their intro calc courses in university over here. Okay, so this topic over here, guys, is going to be like something that you do in your Calculus 1 course and your Calculus 2 course as well in university, right? So this is yeah, so this is going to be kind of the second half of your first year of university. You're going to be studying this stuff some more too. All right, so it's the same idea over here. We have 4x e to the x. We have Fadv, integral of u dv, f u dv, Fadv of uv, Vadu, v du, like this. Okay, so what do we have? We have u equals to 4x dv equals e to the x. That means du equals 4. I put 4 dx here. And guys, the reason why there's 4 dx, let me just back up over here, because this is like du dx equals 4, and that means du equals 4 dx, like this. And if dv equals e to the x, that means v equals e to the x. The derivative of e to the x is e to the x, therefore the antiderivative of e to the x is e to the x. Here's a thing that you need to kind of, how you need to know how to choose this. You want to choose the u so that du gets simpler than what you had before. Now 4 is simpler than 4x was, okay? If my dv is e to the x, well, v is e to the x, so like this didn't change, okay? This say that I'm going to say the similar level of complexity over here, this didn't change, but this got simpler over here. So for we have 4x e to the x equals, so this is Fadv of uv 4x e to the x minus Vadu, v du. We have v e to the x times 4 dx like this. Well, this is equal to 4x e to the x minus 4 e to the x plus c. Okay. Guys, the check is not necessary, but we're going to do it for the first few. Let's go take the derivative of this and see if we get back to this. Product rule, 4x e to the x. I have 4x e to the x plus e to the x times 4 minus 4e to the x. Derivative of the constant equals 0. And these guys are the same. They have e to the x times 4 minus 4e to the x. Those guys cancel out. And we get 4x e to the x, which is what we had originally right here. Okay, so in this case over here, we have u equals 4x and dv equals sine 5x. Now, guys, there's nothing to stop me from doing this though. I could have made 4x dv and made sine 5x u, okay? But again, what we want is when we're looking at this u and this du over here, from here to here, I want this step from here to here to get simpler. That's the key for this stuff over here. We went from u to du. We want this guy to get simpler over here, okay? So I'm just going to do this again. Guys, you could use integration by substitution for this guy over here. I'm not going to. I think it's easier to do this one in your head. Well, what's the antiderivative of sine 5x? Well, it's going to be negative 1/5 cos of 5x. Double check that. Derivative of cos is negative sine. The negatives cancel out. The derivative of 5x is 5, which will cancel out with this guy over here. So we have FUD of Vadu. All right. So we have the integral of 4x sine 5x dx uv 4x times negative 1/5 minus the integral of v du. This is the Vadu part. Negative 1/5 cos of 5x du is 4 dx. I'm just going to clean this up a bit. So we have negative 4x over 5 cos 5x. I have a 4 times negative 1/5, and pull that out in front, it's going to become a positive 4/5. The integral of cos of 5x equals negative 4x over 5 cos of 5x plus 4/5. Okay, so what's the integral of cos 5x? Well, we just did that one. We just did something similar to that. So the antiderivative of cos 5x is going to be sine of 5x over 5 plus c. And there we go. Okay, so that's how this guy works over here. So we get negative 4x over 5 cos 5x plus 4 sine 5x over 25 plus c. And this is our technique for integration by parts. Okay. We have x squared e to the 3x dx. Okay. When we're choosing our u and our dv here, again, from this guy to this guy, x squared becomes 2x. This is simpler. Okay, guys, we want from u to du, oops, that was du equals 2x dx. From u to du, it has to get simpler. In this case, if I have dv equals e to the 3x, that means my v is going to be e to the 3x over 3. The antiderivative of e to the 3x is e to the 3x over 3. Now, yes, this did get more complicated, but really the over 3 is just a constant, guys. And guys, constants, we can just factor them out. Okay, they're really easy to deal with for us. So we're doing our FUD of Vadu, x squared e to the 3x dx uv is x squared, our v is this e to the 3x over 3 minus the integral of v du. We have e to the 3x over 3 times 2x dx. Okay, so what we have over here is like the over 3 and the 2 just becomes 2/3. We can pull that constant out in front, okay? But guys, what we're going to do next is on this part, we have to do integration by parts again on just this part over here, okay? So, guys, I'm going to pause here for a second, so I actually need to get an extra slide here. Okay, so we have this. I'm just rewriting this part over here. Okay, we need to go and do integration by parts again on this guy over here. So I'm going to say let's let u equal x, du dx equals 1. That means du equals dx. dv equals e to the 3x. That means v equals e to the 3x over 3. Okay, so what we have here, this part stays the same. All right, so we have FUD of VDU. Okay, so here's this part is, so here's our FUD of is this part here. UV becomes x e to the 3x over 3 minus the integral of v du. All right, guys, I know this is a bit of a beast of a lesson, definitely a beast of an example over here. But this is how integration by parts works over here. So pardon me for a second, guys. I'm just going to kind of pull up some practice for you guys over here. So guys, if you were still in isolation for this part over here, please come see me first thing in the morning sometime. This is definitely a challenging topic over here, and I do not expect this to be making 100% sense right away. It needs practice like that. You know, there's going to be a few parts like that. Those are definitely going to be difficult for you. Okay. All right. So we have Okay. All right. So here's stuff to practice on integration by parts for you for this topic over here. Again, please stop by, see me in the morning like that. We can go over any questions that you still have. See you soon. Bye.